So there are number of, we can say, operations on the processes. The first is called the creating process. How we will create the process means the new process, destroying processes to destroy the process. If we want to finish that process or delete, then we can call it as destroying the processes. Or sometimes there are number of processes which are running together, and sometimes if some problems come due to the deadlock, then sometimes we can say the destroy of that particular process or killing of process. So third one is the suspending process. Whenever we want to suspend the process, then these are the signals which are you know provided by the operating systems as well as controlled by the operating system, so that the process can be suspended at any time, but with the commands of the operating system. Okay, as per the user requirement, and the user will use some commands, so that with the help of the operating system signals, we can suspend the process. Resuming process, we can again start the process which we have already suspended. Then after completion of the other processes which are running together, then we can start the suspended process, changing a process priority. So this is one of the operations among number of operations. So changing process priority, here we can change the priority of the process. Process means the program under execution. So in case of the multi-programming systems or the multitasking OS operating system, so we can run a number of programs at a time. Then those running or the programs under the execution is called the process. Okay, so we can change the priority of any process which are running, so that we can execute early, or we can handle the related data to that particular process. Blocking process, if we want to block completely and we don't want to work on that process, so that we can block. Okay, so such type of commands you are also using in case of the your mobile system. Okay, like to block any contacts, etc. So whenever you are going to block the any contact, or you are going to block any call, and that time the operating system issue the system call, and as per the system call we can block that particular process. So waking up process, again we are going to start the process if there is a deadlock, and during the deadlock position, or we can say the suspension of that particular process, again we can first wake up the process and then we will start resume the process. And dispatching processes, we want to dispatch any particular procedure or the method, then we can say the dispatching processes. Inter-process communication, if there are again number of processes which are running, then what is the relation and how uh, these processes have the interconnectivity or the intercommunication. Okay, and this is called the inter-process communication. How we will provide the communication among or between the process. Now, process states and state transitions. Okay, so there are a number of process states, and suppose if we are changing the state of the process, then this is called the state transition. So process states the act of assigning a processor. So here we are going to assign the processor. Okay, so whenever the program will run, then that program, or we can say the running process, uh, will be occupied by either the processor or the memory or the IO devices. Okay, or we can also store after running that process onto the secondary storage. So here the act of assigning a processor to the first process on the ready list is called the dispatching. So what is the dispatching here? Dispatch, we are aware by this word, to dispatch any element or to dispatch any mm, new, we can say, the item. So here it is related to the process. Okay. So whenever we are going to assign the process to a particular processor, if it is running, then uh, it is assigned by the uh, operating system to the process, to the processor from the ready list. Ready list in which there are a number of processes it contains, and in the ready list we can provide the priority to the process, as well as um, we can keep as per priority at we can say number one to the process. So our process one will dispatch, okay, to the processor. Then this is called the process state. So the OS may be used an interval timer to allow a process to run for a specific time interval of quantum. So there are number of processes we can say that will wait. Okay, any one process will go to the processor. So where these processes will wait in the ready state. Okay, if there are a number of we can say the process, then mm, they have to wait in the ready list, and after that, as per the requirement of the user or the command of the operating system that is given or written by the user, then the operating system will act accordingly. So there is a particular time, or we can say that there is a time interval which is assigned to a process to run. Okay, if it is in processor, then a particular time interval will be given or assigned to the processor, and this assignment will be done by the operating system. So here each and every operation will be done, or we can say commanded by the operating system. So cooperative multitasking lets each process run to completion. Okay. So after running of the process, it will come to the completion stage. So if there is a multitasking system, then there are several processes are running at a time, but only one process will execute. Okay. Only at particular time interval. So we can calculate the time taken by the processor, how much time will be taken by the processor or the multiprocessor system to complete the task. And we can also calculate accordingly the complexity of that particular program. Now, here you can see state transitions. So when a process is dispatched, okay, so there is a particular area from where the process start to dispatch, it transitions from ready to running. So there are several, we can say, the states. So every process will wait in the ready state, and after the ready state, it will go to the running state. Okay, so there is a list in which there are several, you can say, the processes uh, will wait there, and after that, as per the priority, the processor will choose that particular process, and then the state will change from ready to running. So when the quantum expires, it transitions from running to ready. So this is a particular time interval. If there is some slot, and in that slot, a particular time interval, if the process will not get the command to run that, suppose if there are several processes and you are giving the priority to other process, then the particular time interval will expire, for the other one. Okay, then it transitions from running to ready. It will come back. It will come back because you are giving priority to someone else. Then it will return to the ready list again. Okay, and only that process will run uh, to which you are giving the more priority, and that will go from ready to running state, and another one will return back to the ready state. So when a process blocks, now there is a condition of the block. If the process blocks, then it transitions from running to blocked state. So there are ready state, running state, and blocked state. Okay. So if the process blocks, then it transitions from running to blocked state. When the event occurs, it transitions from block to ready state. So sometimes you want to open that particular space, or you want to run again that process, then it can run and change the state from block to ready state. Okay, so it will depend on the priority of the user. Now here you can check, there are several process states and state transitions. Now in this block diagram, here you can see ready state, and this is the running state, blocked state. Okay, so there is a timer run out. So particular time interval will be given to each process. So from here, you have the ready list. So in this, there are several processes will reside here. Okay, will wait for their time slot. And from this ready state, you are going to dispatch your one of the process to the running state. So any one process can run at a time. It will execute in the processor here. Okay. And from this running state, you can see there is a fixed timer run out. Okay. Here. And from this state, sometimes you are giving priority to the process that is existing in the ready state. But here, as this process will reach to the running state, you want to stop that, and as you will stop, then it will come to the again ready state. Okay, it will return to the ready state, and again here that process will wait to the ready list. So this is the procedure, and how these we can say several states are connected. Now from the ready running state, here, if you want to block a particular process, then this is the blocked state, and here you can send the signal via operating system, and then it will come. Here, your process will be blocked. Okay, and to the blocked process, you can wake up again. As you will wake up this blocked process, then from this state, the signal will go to the operating system, and again that process from the blocked state will go to the ready list. Okay, and same again procedure will go hand in hand, but it will depend on the commands as well as the signals from the operating system. Now there is a process control block and process descriptors. PCB maintain information. So process control blocks maintain the information that the operating system needs to manage the process. Okay, so there are several information, uh, or we can say the related information record of the process that will be maintained in the process control blocks. Okay, that the operating system needs to manage the process, so that operating system can manage the process easily. Now, as per need, the operating system will retrieve the data from the PCB process control blocks, Now we can see here typically include information such as, so there are several information concerning to the process which we are going to store to the PCB and can retrieve as per requirement. So process identification number. So there is a particular PID. Okay, PID means process identification number. So there are several processes which are running in a multi-processor system, in a multi-programming, the multitasking system. So each process have its own process identification number, PID. Okay, and this is unique number. Process states. So the PCB have the information about the process identification number, that is PID. It also have the information about the process states because there are several states you have already studied. What are the different here you can see states: ready, running, blocked. Okay, so this information will reside in the PCB, will store in the PCB. Okay, what is the PCB? Process control blocks. Third one is the program counter. Okay, so this have the information that will store about the program counter. It will increase your uh, process by one. So process, we will get the next process. Okay, program counter will add and select the new process from a list. Okay, that is stored in the PCB. Scheduling priority. Scheduling priority. There are several processes and to which you are giving the priority. That is the scheduling priority. Credentials here. So you can also have the information, authenticated information related to the process. Okay, a pointer to the process parent process. So there is a parent process and it has a pointer so that you have the information about the parent process. Okay, from which old process you are getting the new process. Okay, you are generating or creating the other process. So there is a parent process and also there is a child process. Okay, from the new process you are creating other processes, or we can say sort of multi-threads here. So there is a pointer to the process, that is called the child process, a pointer to the process parent. Okay, that is called the parent process. Pointers to locate the process data, so the data related to the process and instructions in the memory. So there are several instructions which will reside in the memory and also the data. So pointer to allocated resources. Now there are number of resources. Okay, what are the different resources we will use? Tell me, please. What are the different resources? Anybody else?
Sir, input output information,
IO
Input
device
output information, sir.
and
memory management.
memory, yes, and process. Okay, processor, we will
Yes, sir.
processor. Then these are called the resources. Okay, so we can use mm, either the IO devices or the processor or the memory. So the process will reside either in the processor or in the memory or in the IO devices. So the process will go there and it will have the interface with the data. So there are several instructions which will reside in the memory. So here we will use the number of pointers. Okay, so with the help of the pointers, we have the address of the parent process or the child process or the memory location. So we have all the addresses. So with the help of the pointer, these address may change as the process will uh, change the state. Okay, so there is again a process table. Now you can see here the OS maintains pointer to each process PCB. So there is a process PCB, okay, process control block, and the pointer have the connectivity with that. Okay, so with the help of the pointer, you have the uh, address of each location of the PCB. Okay, process control block. So the OS maintains pointers to each process PCB in a system wide or per user process table. So the record of that will be maintained in the process table. So allows for quick access to PCBs. So with the help of this, because we have the pointers, so with the help of the pointer, we have the interface with the process table, and here we have the address of that particular location of the PCB. So we can access to PCBs easily with the help of this process table. So when a process is terminated, we want to finish or complete, we want to terminate, the OS remove the process from the process table. Okay, so the operating system removes the process from the process table and free all the process resources. So during after the termination of the process, the OS will give command, okay, to remove the process from the process table and also free all the process resources. So whatever the resources we were using, it will be freed by the OS operating system. Okay, so here we can say all the commands will be controlled by the operating system. Either the data or the process inside the process table, or it will be occupied by the process resources. So after the termination of that particular process, the OS will free all the resources as well as removes the that particular process from the process table. Now process control blocks, here you can see again process table and process control block. This is the block diagram for that particular. So this is, now you can see here process table. Okay, so this is the process table, and here you can see PCB process control block and PID. Okay, so again you can check, this is the unique number here, and 1 2 and up to n. So there are several processes could be run at a time here, and this is a pointer here. You can check. So in this case, you can see process control block. So you have the idea about this. Here again, this pointer is connected to this process control block program counter, because it has the program counter. Here registers, state, priority. Here you can provide the priority, address space, parent, children, open files, and other flags here. So there are several uh, uh, these pointers have connectivity with this program counter, registers, state, priority, address space, parent, children, open files, other flags. Here this, the third one, the same. So each process have connectivity with the PCB, process control block. Here you can see. Okay, because as there are number of processes which are running, so you have this uh, connectivity with the help of the process table. Process table have interface with the process control block here. How these are connected, and each process control block have the information. Now you can see about the process program counter, register, state, priority, address space, parent, children, and so on. So process operations, now you can see a process may spawn a new process. The creating process is called the parent process. The created process is called the child process. Okay. The creating process is called the parent process. So this is the root one. Okay. From this that is the root process, is called the parent process, and from which you are creating the process. So the created process is called the child process. Exactly one parent process creates a child. Okay, so from the parent process, you can create a child. When a parent process is destroyed, okay, suppose if the process is running and you are creating another process that is called the child process here. Now, when a parent process is destroyed, operating system typically respond in one of two ways. So suppose root process destroyed, then what happens? Destroy all child processes of that parent. Okay. So this is automatically destroy all child processes of that parent, allow child processes to proceed independently of their parents. Okay. Now independently can work. Otherwise, automatically destroy all child processes of that parent. Now here you can see process operation, process creation hierarchy here. So this is the parent process. Now from this parent process, these are called the different child processes B, C, D, and from this child process B, here again this is the subchild process E, or we can again call it as the child process. From this, now this became the parent process BCD, and for these FG, these are the here can say children. Okay, the child process. Again from this, now this became the G as the parent process, and again we will create H and I as the child process. Okay, so this is called the hierarchy for the process operation. Now this is for the Linux operating system process hierarchy in Linux. So here you can see this is the parent process initialization in it, and here you can see KS, WAPD. These are various commands, okay, which we can uh, use for a particular uh, operations on this machine. Then these all commands will act as a child processes. Okay, now here login. Again, this is the parent process for this, and here we can create here. These are the child processes. So this is the different process operations for the Linux. Now suspend and resume here. How we will suspend and resume the process. So suspending a process here indefinitely removes it from the contention. Suppose we want to suspending means it is not definitely we are removing, but it is called the indefinitely. For a particular time duration, we are suspending our process. Okay, removes it from contention for time on a processor without being destroyed. So indefinitely remove suspension means indefinitely removal of that particular process from contention for a time on a processor. Okay, so due to the some we can say the problems on a processor, we are not going to destroy that particular process, but for a particular time, just we are suspending and resume. Useful for detecting security threats and for software debugging process. So why there may be some, we can say the reason for suspension of a process. Suppose it is not working properly, then we can suspend that particular process. Okay. And after that, we can detect the security threats. Maybe the security threats, okay, for that particular process and for software debugging purposes. Suppose we want to debug the particular software, then at that time, at that instant, we can suspend a process. Okay, so there may be several causes, several reasons to suspend a process for a particular duration. And after that suspension, we can again resume the process. So a suspension may be initiated by process being suspended or by another process. It means you are suspending for a particular time, and there may be several reasons or causes, or sometimes it may be possible that you are giving priority to some other process. Okay, so again, for time being, just you are going to suspend that particular process, not for all time or forever. Okay, a suspended process must be resumed by another process. Here again, a suspended process must be resumed by another process. Suppose you are going to start another process, then it may be resumed. Okay, again, the operating system can resume that process. Okay, so two suspended states. So there are two states for the suspended process. First is called the suspended ready, and another is called the suspended blocked. Okay, so from the suspension state, just you are again doing the preparation to come back to the ready state. Okay, so either uh, you can change the state from the suspended suspension to the ready state, or you can block for it finally. Okay, suspended, that is called the suspended block. You do not want to resume again, so you are completely blocking this is, process. Okay, then it is called the suspended block. Or if you want to resume this, then again you will come to the ready state, then it is called the suspended ready. Here you can see the process state transition with suspend and resume. So this is the ready state. Okay, and here you can see suspended ready. So sometimes if you are going to suspend the process, suspended ready state, okay. So for a time being, for a particular duration, just you are going to suspend the process, and here completely blocked, you are completely blocking the processes, and here suspended blocked. Okay, this is the suspended ready and this is the suspended blocked. So this is the permanently you are going to block this, yeah, process, the suspended process you are going to block. Okay, here this is the middle one, running state, and how this have the interface with the ready state, or we can say the connectivity. So just you are dispatching the process. Okay, this is the preceding diagram, and here it contains more number of states. Okay, blocked state, suspended blocked, suspended ready. Now, as from the ready state, this is dispatching the element here to the running state, and the fixed time will be provided here from running state to the ready state. Okay, if the slot here you can see finishes, then it will again come to the ready state. Okay, it will return back. If this process which is dispatched from the ready state, but here it is waiting and the time slot finished for that particular process, then it will return back to the ready state, and it will be dispatched again by the operating system to the running state. Okay, so it will check that which state is here, you can say free, and if there are several processes are waiting, then it will come back, or as per the priority, you can run the process here. So this the suspended ready again have the connectivity here. Suspend signal will go to the suspended ready here. Again, you can resume the process. So as it will resume, then it will again come to the ready state, and from this ready state, it will again uh, come to the running state. So now here you can check from the blocked state, it also have the connectivity that it may resume the process, that is called the suspended, blocked, or it may be permanently blocked here, suspended. Okay, so this have the connectivity with the suspended blocked state. So these are called the suspended states, and these are the active states here. So this area, now from this area you can check, this is the active state and this is the suspended states. Here you are going to permanently suspend the process. So the below area here, from this line you can say the area for the suspended states, and here you can say the active states because it contains here ready, running, okay, and this is for the blocked state, but here you are again returning to the ready state. Okay, so you can resume here, you are not permanently blocking this, if then it will come back to the, this process will come back to the ready state. So this is the diagram for the process state transition with suspend and resume. Means the process which will be suspended by the user here, then how it will resume or start again. So this is called the suspend and resume process. Now I am taking your attendance here. So any query till now? Any question?
No, sir. No, sir.
स्टूडेंट्स क्लास में क्यों नहीं आ रहे हैं? इतने हम लोग क्यों नहीं